Welcome. Today we take a new chapter, binomial theorem, for discussion. So first of all, I discuss few important points and formula of that chapter. Binomial theorem actually is expansion of that type a plus x to the power n. Binomial, bi means two terms to the power some integer n. Here n is integer. Its expansion is a to the the nc0 a to the power n into x to the power 0 plus nc1 a to the power n minus 1 x to the power 1 plus nc2 a to the power n minus 2 into x to the power 2. This way, last term is ncn a to the power n minus n into x to the power n. So, ultimately, it has n plus 1 terms because its suffix is 0. Its suffix is 1. 1 is corresponding to the second term. Suffix 2 is corresponding to the third term. So this is corresponding to n plus 1 terms. Normally, we use this term, capital CR means NCR. N mind that n is a positive integer. Each term, you see, consists of three factors. One is of the type NCR, other is a to the power something, and next one is x to the power something. If this is known NCR, then a to the power will be n minus that. Here say NC2, a to the power n minus 2, that difference, and x to the power 2. On the contrary, if it is x to the power 2, it must be nc2. That is, coefficient of x square will be nc2. Coefficient of x to the power 5 will be nc5, and so on. Next. General term of that, it is normally known as TR plus 1. That is, R plus 1th term, this is equal to NCR a to the power n minus r and x to the power r. We have taken r plus 1 because if it is r plus 1, then it is NCR simple 1. R plus 1th term, of course, r plus 1th term of that expansion. Middle term. As I told you just now, that number of terms of this expansion is n plus 1. And middle, sometimes you have to calculate middle term. Middle term, if it is, say, a plus x to the power 10, so it has 11 terms. So its middle term is middlemost term of 11, which is nothing but 6 terms. Normally, it is middle term is t n by 2 plus 1. If n is even and if n is odd, then it is t n plus 1 by 2 and t n plus 1 by 2 plus 1. In that case, when n is odd, in that case, it has two middle terms. For example, if a plus x to the power 3, it has four terms, 1, 2, 3, 4. It has no single middle term, two middle terms. The sum of all binomial coefficients, this is NC0, NC1, NC2, etc., they are known as binomial coefficients. Sum of all binomial coefficients is binomial coefficient is 2 to the power n. This can be obtained always by putting this is 1, this is also 1. 1 plus 1, that is 2 to the power n. By putting a is equal to 1 and x is equal to 1, so this become, you see, nc0 into 1 plus nc1 1 into 1. So all terms excepting binomial coefficients will be 1. So it is 2 to the power n. Sum of all binomial coefficients of a minus x to the power n, sum of all binomial coefficients of that, it is obviously 0. Because by putting a is equal to 1, x is equal to 1, this is 0 to the power n, so 0. From there, we can calculate C0, that is this one, C0, and C0, normally I write it as capital C0 plus. It is actually, you see, C0 minus C1 plus C2 minus C3 and so on. This is equal to 0. So from there, we can calculate that C0 plus C2 plus C4, that is sum of all even position terms, is equal to C1 plus C3 plus C5, sum of all even binomial coefficients is equal to sum of all odd binomial coefficients, and it is actually equal to this divided by 2, that is 2 to the power n minus 1. So next, in the binomial ax plus b by x to the power k to the power n, in that binomial term containing x to the power r, say, can be calculated or obtained very easily simply by counting. How? Uh, you see, in that expansion, first term contains x to the power n. Accepting a is constant, I am calculating only a power of x. It will be x to the power n. Next term contains nc1 into x to the power n minus 1 into that is 1 by x to the power k. That is, this term is actually x to the content x to the power n minus 1 plus k. Second term will be nc2 x to the power n minus 2 into 1 by x to the power k whole square. That is, this term will contain power of x to the power n minus 2 minus 2k. That is x to the power n minus 2 into 1 minus k, 1 plus k. That is, a first term will contain x to the power n, and for all other subsequent terms, the power of x will be less by 1, and k, that is n minus 1 plus k. Two property NCR, that is CR, is equal to NC n minus R. And number two, NCR minus 1 plus NCR is equal to n plus 1 CR. That is, NCR will be equal to NC n minus R. And very easily you can calculate by simply by calculating NCR. And you know, NCR is equal to factorial n by factorial of n minus r into factorial r. NCR is equal to that. Simply by calculating the here, this is equal to that. Simply by putting value of this and that, you get that. And here, in second property, NCR minus 1 plus NCR, both upper suffix is n, and it is r minus 1 and r consecutive two terms. Then result will be, this will be increased by 1, and this to be taken, which is more between this and that. For example, 8C2 plus 8C3, this is equal to 9C3. Next, among binomial coefficients NC0, NC1, NCn, that is n plus 1 binomial coefficients, greatest one is NCn by 2 if n is even, and If n is odd, then it is nc n minus 1 by 2 and nc n plus 1 by 2. Greatest will be this and that. In fact, they in that case they are equal. One, another property. 1 into nc1 plus 2 into nc2 plus 3 into nc3. This way, plus n into ncn. It is equal to n into 2 to the power n minus 1. Okay. Now let us take few problems of that chapter. First problem is, if the coefficient of second of problem number 1, second, third, comma, fourth term of the binomial expansion 1 plus x to the power n are in AP, second term, third term and fourth term of that binomial expansion are in AP. In that case, n being a positive integer, then sum of coefficients of all odd powers of x. Sum of coefficients of all odd powers of x. Options 68, 64, 66 and 72. Now let us see the problem once more. In that binomial coefficients, binomial expansion, second term, third term and fourth term are in AP. Fourth, given second, third and fourth uh, binomial coefficient of that expansion, not terms. Second, third and fourth binomial coefficient of that expansion are in AP. Then to find the sum of all binomial coefficients, odd binomial coefficients. We know that sum of all binomial coefficients is 2 to the power n, because we have to put this 1, it is already 1 and this also 1, so 2 to the power n. And sum of all binomial coefficients which are in odd positions, this is this divided by 2, that is 2 to the power n minus 1. So to know the all binomial coefficients, sum of all binomial coefficients in odd positions, it will be n by 2, 2 to the power n minus 1. But before that, we have to find what is n, what is exact value of n, because in answer, numerical values are there. For that purpose, this property to be used, because these terms are in AP. Now, for this expansion, second term Second coefficient is NC1. Third coefficient is NC2. And fourth coefficient is NC3, given that they are in AP. Therefore, NC1 plus NC3 is equal to 2 times NC2, giving NC1 is simply n plus NC3 is factorial n by factorial 3 into factorial n minus 3 is equal to 2 times NC2. NC2 is, uh, you can keep in mind, NC2 is always n into n minus 1 by 2. So 2 cancels. This is n plus factorial n and factorial n minus 3. Most of the terms will be cancelled, leaving n minus 1 into n minus 2. After that, factorial n minus 3 is cancelled with that. By factorial 3 is 1 into 2 into 3 is 6 is equal to n into n minus 1. So 6n plus n minus 1 into n minus 2 minus 6n into n minus 1 is equal to 0. Taking n common, we have 6 plus these two factors, that is n square minus 3n plus 2. After that, n had taken common, so minus 6n plus 6 is equal to 0. But n cannot be 0 because if n is equal to 0, this to the power 0, so its first term, second term, third term not possible. So we have n square minus 9n plus 14 is equal to 0. So that n into n square minus 7n minus 2n plus 14 is equal to 0. So that it is n minus 7 into n minus 2 is equal to 0. Now either n is equal to 2 or n is equal to 7. But n is equal to 2 is not possible, because if n is equal to 2, power is 2, so highest power is x square. But second x square means it has only 3 terms. But you see, it is given that at least 4 terms are there. So n is equal to 7. So that we get n is equal to 7. So n obtained. Now, sum of all odd position terms is 2 to the power n minus 1. Hence, our answer is 2 to the power 7 minus 1. So 2 to the power 6 is equal to 2 to the power 6 is 64. So 64 answer. Next problem. Problem number 2. If factorial 1 plus factorial 2 plus factorial 3 up to factorial 95 is divided by 15, the remainder is options 0, 11, 3 and 14. Now question is, one expression is given which is factorial 1 plus factorial 2 plus factorial 3 up to factorial 95, a big number. If it is divided by 15, what is the remainder? Now factorial r, I think you know it, factorial r is equal to 1 into 2 into 3 up to r. All positive consecutive integers 1, 2, 3 up to r. So this one is very big number. So altogether it is a very big number. Now first one is factorial 1. Factorial 1 is 1. Factorial 2 is equal to 1 into 2, that is 2. Factorial 3 is equal to 1 into 2 into 3, 6. They are, none of them are not divisible by 15 because it is far less than 15. Now factorial 4, it is equal to 1, 2, 3, 4, 12, 24. It is more than 15. So when this is divided by 15, only this number, uh, uh, 15, so 9 is remainder. After that, after factorial 4, factorial 5, you see, it is equal to factorial 5 is equal to 1 into 2 into 3 into 4 into 5. 3 into 5 are two factors, so it is divisible by 15. Factorial 5 is divisible, completely divisible by 15. Next one, factorial 6. It is factorial 5 into 6. Factorial, as because factorial 5 is divisible by 15, so this is also divisible by 15. So all terms after factorial 5, all are divisible by 15. Then remainder will be factorial 1 sum, factorial 2, factorial 3, they together, this is not also divisible by 15. So sum is factorial 1 plus factorial 2 plus factorial 3 plus factorial 5. This sum is not exactly divisible by 15. It is 1 plus 2 plus factorial 3 is 6, factorial 4 is your 24. This is actually equal to 30, 33. This part, sum of this part is 33. After that, all terms are divisible by 15. So up to this, sum is 33. When it is divided by 15, remainder is 3. Because 15 into 2 is 30, so remainder is 3. So up to this, remainder is 3, and all other terms are exactly divisible by 15. So total remainder is 3. Next. Next problem is, okay, we stop today here. And next day, we discuss few more problems. So, thank you for today.